All right, boys and girls, welcome back to the drive-through. Special shout-out to my sophomore chatty table and their little discussion on sleep right now. I'm enjoying it. Here we go, 9-7, almost done, Carson. So I encourage you to pause the video and read this. Hopefully you already have. What you're going to find is now we are graphing the information differently, but it's the same information from the last video. Okay? So now they've averaged the men's salary and the women's salary for a given year, and they've made that a data point. So for the year 2011, for the year 2011, women are going to be on the x-axis. That was the average women's salary. And the men are going to be on the y-axis. Okay? And then we're going to plot all that data. So what this tells you is if a woman averaged like about $17,900, then a man averaged about, I don't know, $33,000. This point tells you that if a woman averaged like $19,100 or $200, then a man that same year would have averaged $32,500 or something like that. Does that make sense? So that's what we're graphing. Now, this is like, I realize from talking to some of my friends, this is an important question. And I thought, like, how in the hell are they going to be able to do this? They just want to ask you this, Carson. Would you say that this correlation coefficient is a high correlation, an average correlation, or a low correlation, based on how far away from these lines, or from the line, are these dots? I agree, they are pretty far away. So would you say it's a strong, average, or weak? I would agree. So we're going to say this is a weak, positive correlation, right? So give me a number that could be our correlation coefficient. Love it. Carson guessed 0.4. I love that guess, okay? Now, estimate the average income for men in this time period. Describe how you would do that. Yeah. Excellent. Carson just asked a great question. He said, what do you consider strong and weak? And Mr. Crow and I had this very debate. From a general algebra 1 standpoint, Carson, above 0.5 and below negative 0.5, we might start considering it strong. But from an engineering standpoint, we want it to be like 0.99, 0.96, 0.95, way up close to 1. Because if we're building jet engines based on this data, we need to be damn accurate, very accurate. Does that make sense? Exactly. People's lives are, at line. So that's a great question. We're going to say anything above or below 0.5 or negative 0.5 is strong. Anything around the 0.5 area would be maybe average, and below that would be weak. Okay? All right, so based on, how would we find the average men's salary?
You could, that's the mean. You could go into your calculator.
You could put all of this into your calculator and find the mean, which is the way you did. You could, draw little lines down for every single point. Oh, no, I'm drawing the lines the wrong way, aren't I? You could draw lines over here for every single point. And all of those give you the men's salary during any given year, okay? But to find the average quickly, I would have to add them all together and divide by 15. But it says estimate. I'm just going to say it's somewhere in that range, Carson? Somewhere in the middle of my dots. I'm going to estimate that this right here is my average salary, because I'm going to move on. How about $34,500? Now, I actually have the answers to both these questions, so I'm curious. Just so you know, the actual correlation coefficient for this one is 0.64. Not bad. That's a great guess. And the actual average salary, sorry, that should have been, that just, you got ViewSonic, is $34,000. So we did really good with our estimate for that. Okay? We're moving on. All right, what's the average income for women? We'd find it in a very similar way. Uh-oh, no. For the women, we would go down, and those correspond to the average women's salary during those years. Let's find a relatively central point for women. I'd say it's these. We're going to say it's right around here. I would guess 19,400 would be my guess. Now, let's see what it actually is. 19,200. Not bad, okay? All right, so they find their regression line to be this. What does the slope of the regression line tell you? Now, let's think about what our graph is. What's down here? Women's income. That's our X. That's our input. Our men's is our Y. So if you look at our equation, Y equals 2.1x minus something. What does that mean? What does the slope mean?
It means that it's increasing by 2 points.
Okay, you're right, but it is the real question here. Carson's answer was right. It means that it is increasing by 2.18. What salary? I think what it means, remember, the men's salary is Y. So for every dollar that a woman makes, a man makes $2.189 more. But you have to subtract out $6,700 at the end of the year. Do you understand? That's what it's telling us. So if a woman makes $20,000 in a year, multiply that by a little more than 2, 44,000. Subtract 6. That if a woman makes 20 during that same year, a man's going to make about 36,000. Does that make sense? That's what it's telling you. Okay, I think those were precise units in language, don't you? All right. So it said Leo's saying that it's not fair, and then they're like, well, let's start looking for data with men's with bachelor's degrees or more. They found that the correlation coefficient for average salary versus year was now R equals negative 0.94 or 0.84. Now, if R is negative, all that means, Carson, is that the data is trending downward, so the slope is going to be negative.
That means if you have more school, you're going to make less money.
No, I think it means that if you have more school and you've got women down here and men here, that actually a more educated woman might start making more money than a man. So it might pay off more for a woman to go to college than a man. Okay? Predict what the graph might look like. Well, it's going to be a negative slope, and the points are going to be more closely scattered to the line than before, because now our coefficient is 0.89 and before it was 0.6. We're moving on. All right. So there it is. There's the actual scatter plot for salaries for men with bachelors. So let's see. Income with men, salaries with men. Let's see. The actual salaries for men. So here's their salaries. What is this saying? I'm going to pause it. All right, got it. I got it. I thought this said 2000 to 2001. Okay, so down at the bottom of our graph this is the year 2000. This is the year 2012. Okay? And now we're just looking at men again. So in 2000, if you had a bachelor's degree, you made close to $70,000. In 2012 or 11, if you had a bachelor's degree, you're making $62,000. So now what's happening is the value of a degree is decreasing. Okay? There's more and more people going to college, and there are more specific jobs needed. So a general college degree doesn't do for you now what it did in the year 2000. Okay? That's what this says about the income of men from 2000 to 2011. The salary was decreasing by about $588 per year. Okay? Now, they turn their attention to data for women. Analyze the data by creating a scatter plot. So it looks like we're going to go from 40,000. I can't write on this thing down low. From 40,000 to 44,000. Okay. And then let's see. This is going to be 41. 42, 43. And then these are going to be years. So I'm going to scroll down a little. I want to make sure I can see both of those things. Here, this will be 2000 to 2011. Now I hate this. Look how they've done this. They've given us to us backwards, Carson. So in 2000, we had 43,002. All right, in 2001, we had 42,009. 2002, we had 42,008. It's a small decrease. Then we had 42,009, just a small increase. Then 42,005, bigger decrease. 42,006, a little bit of an increase. 44,000, really, a big jump in 2006. 44,001. And then way down to 42,000. That must have been the year the market crashed. Up just a little bit. Up again, is that what you said? Down again, thank you. And then down even more. Okay, so I'll try to make these into bigger dots so we can interpret them all the same. Okay. All right. For consistency with the men's graph above, okay, we did that. Draw the graph, report your analysis. Be something like that. It's going to be a negative. Now that you have analyzed the results for women, compare the results for men and women. I think what we should do is get a regression line for this. Okay, can you put this in your calculator for me? So let's see, we're going to go to here. We're going to resize this window. Okay, so we got to put in some lists. Okay, so let's go lists. Now let's go to stat, edit. All right, the first list is going to be easy. The year 2000 is a 0. Okay, and then 2001, 2002, 2003, 2004, 5, 6, 7, 8, 9. Where are we going to? 11, 10, and 11. Now, this list, ready? If you got to go, go.
No, I don't.
Read them to me. 43293. Enter.
4299.
42992. Enter.
428.
42871. Enter. 42954, enter. 42539, enter. 42690, enter. 44007, enter. 44161, enter. 42620, enter. 42746, enter. 42409, enter.
And 41338.
Okay. Now, let's go quit. Let's calculate. No, let's go stat. Calculate. Linear regression. I think I got to turn it back on probably. I got to turn my, what are those things called? Diagnostics.
Yeah, you gotta go.
Okay. But we can see, without looking at my correlation coefficient, because I'm going to try to move this video on. Hopefully you remember how to go into your settings and turn your, what's it called?
Catalog. Diagnostics on.
You got to turn your diagnostics on to get your correlation coefficient. But now we know that during the same period of time, Carson, the women's slope only decreased by $80 per year. So for women with bachelor's degrees, their data had a significantly less of a decrease than the men's slope. Does that make sense? Does that make sense?
Yeah.
Okay. So now we've talked about that. And I think that's it. Nope.
Oh.
So Leo believes that the difference in income between men and women may be explained by the differences in education, but Aracelli believes that there must be other factors such as discrimination. Based on the data in this task and getting more money, make a convincing case to support either Leo or Aracelli. I'll leave that to you guys at your tables. What other data would be useful in making your case? For me, I want to compare female CEOs to male CEOs. I want to compare female teachers to male teachers, female doctors to male doctors. That's the data I want to get my hands on. At that point, I'd be able to make a better conclusion. Boom!